Hello guys, welcome back to my channel. Hope you're all doing well. So in this video we'll be trying to solve the 7th Leetcode problem, that is reverse integer. So the statement is basically like, assume we are dealing with an environment that could only store integers within the 32-bit signed integer range, that is minus 2 raised to 31 to 2 raised to 31 minus 1, basically ASCII. For the purpose of this problem, assume that your function returns 0 when the reversed integer overflows. So your first example 1, 2, 3, the output is supposed to be 3, 2, 1. Then example 2 minus 1, 2, 3 minus 3, 2, 1, and like that. Similarly, example 3, 1, 2, 0, it should be 2, 1, not 0, 2, 1. And yeah, so now let's see how we can solve this. Okay, so now how can we solve this? Let's say they gave us a number 454. So what a normal person would do is they would just keep a variable answer to get the modulus, right? 454 modulus by 10. Then a variable x to divide it. Something like this, right? Okay, and then you would do r equals r into 10 plus answer. And then you would get the answer, right? So at first, so all this will be in a while loop. So we must take all this, put this down. So it will be while x, alright, let's just say x equal to 454. So while x, all this will happen, right? So first answer will be, so first answer will be equal to 4, then x will be equal to 45, and then r will be equal to 4, right? Similarly, what do you say? Then answer will be equal to 5, x will be equal to 4, and r will be equal to 45, right? And then answer will be equal to 4, x will be equal to 0 actually, and r will be equal to 454. So now r is your answer, right? Okay, so for a non-negative integer it's actually very easy, but the actual catch comes when a negative integer comes. So now why is that? So let's say, for example, instead of 454, let's say I had something like negative 1 to 4. So now what would happen? Now the modulus, for the first time when you run this, the modulus of negative 1 to 4, most people would expect it to be 4, but no, it will be 6. The modulus of 1 to 4 will be 6, right? Because it is a negative number. Similarly, when we do the floor division with minus 1 to 4, let me erase all this first. So when we do the floor division as well with minus 1 to 4, we will be getting 13 as the answer. Why is that? Because when we do floor division, we'll get something like minus 12.4, right? So floor division will round the number off to the smallest value. So in this case, the smallest value is minus 13, right? Because we are going backwards. So minus 13 will be the smallest value. So how do we stop all this from happening? So I'll be explaining the floor division part first. So instead of doing floor division, we could do something like integer of number into 1.0 to make it a float divided by 10. So you do like this. For minus 1 to 4, we'll get the answer as minus 1, 2. Okay, so now this problem is solved. Now for the modulus, what can you do? So as I mentioned, if you do modulus of minus 1 to 4, you won't get 4, you will get 6. So how do you get 4 from that? If you do, so now for modulus, if you do something like minus 1 to 4 modulus by minus 10, then you will get the answer as 4. So these are the two ways to solve the problem, like when it comes as a negative number. But for the positive number, like, it's pretty straightforward, right? Yeah. So yeah, that's basically it. So now let's get into the coding part of this. But before that, they also gave a constraint for this, that is min int and max int. So the min int is like -2 raised to 31, and the max int is 2 raised to 31 plus 1. So it's not supposed to exceed that. So what we can do is we can just do something like if r is more than max int, what we can do is we can just return 0, right? Because it's exceeding the limits. Similarly, if r is lesser than min int, we can again just return 0 as the answer. So yeah, that's basically it. So that's how you solve this problem. So now let's code this whole thing out. Okay, so let's code this whole stuff out. So now, as I mentioned, we need two helper functions. The first one will help with our division. So this is gonna be number, comma, then we can just put d for the divider. So what this will do is it will return the integer value, right, of number into 1.0. We like need to do this to get the correct value for positive and negative by d. Okay, so now our second helper function, we need to find the modulus. So I can do something like mod, then number comma m. So if number is more than 0, all right, if it is more than 0, what should we do? Then we can like just do the exact same way, return number modulus m. Else what should we do? Else we can return something like return number modulus -10. So yeah, those are our helper functions. So now we'll put r, which will carry our result default as 0. Then we should store our max int and min int. So according to the question, max int is equal to 2 raised to 31 minus 1, and min int is equal to negative 2 raised to 31, right? So yeah, then here comes our main loop. So while x has any elements, because we don't want to go beyond 0, so while x has any elements, then we can find out the answer. So our answer will be basically mod x comma 10. Then we can find x. We have to update the value of x. So this will be division x comma 10. And yeah, I guess that's it. Then we have to update the value of r. So r will be equal to r into 10 plus r into 10 plus answer in this case. Okay, now we have to check if it goes beyond the max int and min int range, because we if the r goes beyond the max int or min int range, we have to return 0 as the answer. So I can just put if r is bigger than max int, then what should we do? Then we can return 0. We can just make this a bit more shorter. If it is bigger than max int, or r is smaller than min int, then we can return 0. That's basically it. And then if it passes all the conditions, we can return r as the answer. So let's see if this works. And yeah, it works. Let's submit this. And there you go, it works. But why is it so slow? 9.13%. I think there's some glitch with this. Let me just rerun this. Yeah, there you go. Now it's 90.22. So that's basically how you solve this problem. It's kind of hard, but it's understandable, right? So as usual, don't forget to like and subscribe. And I'll see you in the next one. Bye.